Hello, this is Amy speaking. Today I will be presenting to you all the anti-gravity water demo. So, how does it work? The anti-gravity effect created by the water is an optical illusion. By flashing the LED lights at a frequency close to the frequency of which the water droplets are being pumped out, a stroboscopic effect is created. It appears to us that the water droplets are almost even levitating, or even moving upwards or downwards. What is this stroboscopic effect? It's created when a light pulsates at a certain frequency, illuminating some kind of periodic motion. It can be rotary motion, which you may notice when watching videos on YouTube because of the periodic motion of a wheel or propeller filming at a certain FPS. An important feature of the actual anti-gravity water setup is the speakers sitting on top of this whole thing. Take a peep at this really unnecessarily high quality photo and check them out. The one on the left is made this year with a specifically 3D designed nozzle that aims to provide laminar flow. The one on the right was made by the wonderful group last year. And let's take a closer look at that 3D nozzle. There is two important parts that I want to stress here. Number one, obviously the entry for water, and number two, the nozzle tip. If you look closer, you'll notice there's a hexagonal pattern that allows for more even flow of water. So, what is the point of these speakers? Their main purpose is to ensure that the water that is being pumped out is at a certain quote-unquote flow rate. That means we're ensuring that the flow is reliably consistent and in turn able to create that previously mentioned optical illusion. So, here's the setup. I'm doing a voiceover, by the way. So in the bottom right corner, you'll notice that box that controls the strobing of the lights, and then the two items in the middle, the one on the right is the amplifier, and the left controls the frequency, and those two are connected to the left speaker. And then you see I'm pointing along those wires right there. That one's connected to the right speaker, and then that one ensures that that right speaker stays on a certain frequency. And then just a disclaimer, as I'm looking more closely at all the circuitry and the Arduinos, that all the power supplies are unplugged, so I'm not scamming you. It's just to make this setup look more pretty, because before it looked awful. There was a lot of wires going on, and it just generally is kind of wire hell, essentially. To quickly go over what is connected to the right speaker, here's the code, bam 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 bam. And I recommend watching last year's Steep video as they go more in depth about that. Now, for what is connected to the left speaker, that's all new. This specifically here is our Arduino coded to control the wavelength, aka the frequency of the speaker. This is capable of controlling how many times one cycle of a waveform is repeated per second. Our goal was to make at least one or two speakers this year adjustable, not just the strobe lights. And that is why we were able to have one stream seemingly go up, while the other seems to go down. And here's all the code and schematics that go with this whole shebang. And credit is given where credit is due. Please check out this YouTube channel. This tutorial was incredible. This doesn't only control frequency for speakers, but it also changes their actual waveform, which is very cool. So once again, totally would recommend checking it out. Yay, you made it to the end of the video. Wow. Thank you for watching. I hope you enjoyed, and hopefully next year there'll be some cooler additions. I'm excited to see what the next year group does, or if I'm in it again. It highly depends, but I'll just let this video play out as it strobes at you because the FPS of the video is too high. Catch you all later.